Well, hello everybody. As you know, Chemistry Cat loves moles. So we are going to continue our work in Chapter 10. You will need a periodic table and a scientific calculator. I hope you've accessed your notes so that you can fill them in as we are going through them. So we are going to be doing molar conversions using dimensional analysis. If you recall, that's just a fancy term for factor label method. And really, dimensional analysis, you're starting off with one unit, and you will be converting to another unit. Say it's X unit, and basically you put X unit down here, usually with a number, and you have a different unit, say Y unit. In order to get X unit to cancel off and convert it to a different unit. So we get Y unit. And you'll see what I mean about this in just a moment. Okay, so we are going to be using something called molar equivalence in order to cancel units out and reach our desired unit. And you're going to need to show all of your work and include proper units, and proper units will cancel off, and you'll wind up with a different unit in the end. So, molar equivalence. We've already learned about determining molar mass using our periodic table. So, the molar mass that you determine for a particular compound or substance has 6.02 times 10 to the 23rd particles in it, like molecules, atoms, ions, whatever it is that you're dealing with. That is also equal to 1 mole. All of these are equivalents. They are equal to each other, and we are going to use those in our calculations. So for instance, molar equivalents for water. 18 grams of water has 6.02 times 10 to the 23rd molecules of water, which is equal to 1 mole of water. Now, how did we come up with the 18 grams for water? Well, if you recall, figuring out your molar mass, we've got hydrogen and oxygen in our water formula. We've got 2 atoms of hydrogen, 1 atom of oxygen, and you look up the atomic mass on the periodic table, round it to one place past the decimal, and multiply, and then add up those numbers to get your total. So 2 times 1.0 is 2.0, and 1 times 16.0 is 16.0, and we add those two numbers up, and that's where our 18.0 grams, and we were using grams per mole for molar mass. And for our purposes today, we can just use the 18 grams because that is equivalent to a mole. So all of these here are equivalents of each other. So for molar conversions, we can go from gram to mole. And mole is abbreviated MOL. We can go from a certain number of moles to grams. We can go from grams to number of molecules. We can also go in the reverse. If we have a certain number of molecules or atoms or formula units, we can convert that to grams. We can also go from molecules to number of moles, or we can go from number of moles to number of molecules. So these are the 6 different types of molar conversions that we are going to be doing today, at least in your homework. You will experience all 6 of them, and we're going to work through a few examples. Okay, so our first example today, we have 152.0 grams of NCl3, and we want to convert that to moles. So we always start with the given. We have, as our given, 152.0 grams of nitrogen trichloride. So we're going to write down the 152.0 grams. We have to identify our substance, NCl3, and in order to get this gram unit to cancel off, now the gram unit right now is in the numerator position, and in order to get it to cancel off, it must go in a denominator position. So we're just going to put gram NCl3 here, and we are converting to moles. Now we have to come up with a number to put with our grams. Okay, this is where your periodic table comes in handy. Okay, so grams, you know how to figure out molar mass. We've got 1 nitrogen in our formula, and we have 3 chlorine atoms in our formula. We have to look up the atomic mass. Nitrogen is 14.0. And if we look up chlorine, chlorine is 35.453, and we want to round to one place past the decimal. So that will round to 35.5. And again, it's really important that you have mastered rounding to one place past the decimal. So 1 times 14.0 is 14.0. And 3 times 35.5, let me get my calculator, it's 106.5. Now that we have these numbers, we're going to add them up. That brings us to a total of 120.5 grams. Okay, we're just going to stick with the grams. We'll put that number right here, 120.5 grams. And since we are converting to moles, our mole unit has to go on top. Now, what number always goes with the mole? 1. Okay, whenever you're doing molar equivalence, and you want to know how many moles in the molar mass, that's in grams, of your substance, it's always going to be 1 mole. So the gram units cancel off. And of course, our substance, I should put that up here to be proper, NCl3. Okay, so we're going to take 152 times 1 divided by 120.5. That comes out to be 1.26141, blah, blah, blah. And we want to have at least 3 significant digits. We really should have 4 because this is in 4. So I guess to be proper, 1.261, and the unit is the mole, and our substance, NCl3. So this is what we are after right here. This is our final answer. So we've converted 152 grams of nitrogen chloride into moles. So there's 1.261 moles in the 152 gram sample. Okay, so there's example 1. Let's move to example number 2. How many molecules are in 67.5 grams of water? Well, we always start with the given, 67.5 grams. H2O is our substance. And I need to get the gram unit to cancel off. So where does it go? Does it go on the top or on the bottom? It has to go on the bottom. It's got to go diagonal. So my gram unit will go down here. My substance is water. And I need a number to go with the gram. Where's that number going to come from? Molar mass, periodic table, 2 hydrogens, 1 oxygen. Atomic mass of hydrogen is 1.0. Atomic mass of oxygen is 16.0. Okay, multiply, add up, 18.0 grams, and that number is going to go right here, 18.0. Okay, I'm asked to determine how many molecules. How many molecules? Well, what's that magic number that goes with molecules? Avogadro's number, 6.02 times 10 to the 23rd power. And I need to put a unit. Well, my unit is molecules. Now, don't try to abbreviate molecules. You have to write it out. Okay, so that's my unit. And I have to put my substance down also, which is water. The gram units of water cancel with the gram units of water. I'm left with molecules of water as the unit and substance that I have to solve for. So you're going to take 67.5 times 6.02 times 10 to the 23rd power. Then you're going to divide by 18. So it might be helpful to take the 67.5 times 6.02 times 10 to the 23rd power, hit the equal sign, and then divide by 18. Now, that comes out to be 2.26 if I round to 3 significant digits. Okay, this is in 3 significant digits, our initial given. So we want to keep the 3 significant digits. And way over on the right, in very, very small numbers, it says on my calculator times 10 to the 24th power. So important that you look and see and write that. My unit is molecules. Not only do I have to put that unit in my work, I have to put it in my answer. And I also have to write my substance, water. Okay, so this is my answer. Now I realize that when you're doing this on your notes and you're typing them in and on your worksheet that you can't circle your answer. If we were in class, we would be circling our final answer and canceling off our units. Okay, now you can still type in the units and the substance with no problem, but canceling the units is probably not quite so easy unless you use that strike through feature. So let's move on to next problem. Our final example problem. How many moles are in 3.86 times 10 to the 23rd molecules of carbon dioxide? Now, this, in some of your problems on your homework, it might give you atoms instead of molecules. It might also give you formula units instead of molecules. Okay, but this is our given. 3.86 times 10 to the 23rd molecules. Wow, my writing is terrible. CO2, carbon dioxide. I have to get rid of the unit, get it to cancel off molecules, carbon dioxide. So where's it going to go? Top or bottom? It's got to go diagonal to it. Now I'm going to leave a big space here because I need to put a number with my units. What number is going to go with molecules, atoms, or formula units? Or ions, maybe? What number always goes with the molecule when we're doing molar equivalence? Avogadro's number, which is 6.02 times 10 to the 23rd power. Okay, now I need to determine the number of moles. Moles, my desired unit. MOL for short. What number always goes with the mole? 1. Okay. If you think you've got 1 mole digging up your garden, okay, 1 mole. And our substance is CO2. Molecule carbon dioxide cancels with molecule carbon dioxide. Now, whenever you're putting this into your calculator, you can simply type in 3.86 times 10 to the 23rd times 1. You don't really have to put that in there. But when you go to divide, you're going to need to hit the division sign and put a parenthesis, then type 6.02 times 10 to the 23rd, and parenthesis, then hit the equal sign. Depending on how you're doing your exponents, if you're using that times 10 to the caret 23, then you absolutely have to use a pair of parentheses in there. If you are using your EE button, which means times 10, and then you put in 23. okay, then you don't really need to use those parentheses. It's going to work out for you. So put this into your calculator right now and see what answer you get. You may want to try it with parentheses around this denominator of 6.02 times 10 to the 23rd, and try it with and without. See what answers you get. Okay, I came up with 0.64119 blah blah blah. Okay, so I'm going to keep 3 significant digits because that's what I have in my original given. So I'll keep 3 significant digits. My unit is the mole, and my substance is carbon dioxide. And that is our final answer. Ooh. Now, if you came up with some crazy power, now I'm going to put this into my calculator without using those parentheses. Using my little times 10 to the caret 23rd power, I get 6.41 times 10 to the 45th power, which is absolutely wrong. Okay, so that's why it is so important for you to use parentheses whenever you're dividing by 6.02 times 10 to the 23rd. Anything with a power in your division, got to use those parentheses. Okay, folks, that ends our notes for today. You've got a worksheet with 8 problems on it, and you've got today all weekend to work on it. It is due Monday morning. Okay, good luck. See you Monday.